You know you're recording, right?
Oh, Welcome back to Higher Theory. This is episode 2 of our ClipShow build series. For those just joining us, ClipShow is a live streaming integration that allows viewers to pay real money to have their approved social media clips displayed live in real time on the stream. Think of it as a way for streamers to monetize their audience engagement while giving viewers a fun way to interact with the stream by sharing clips that everybody can see. In today's episode, we're going to make some serious progress on the system that makes all of this work. We're going to start by getting our dashboard layout configured and dialed in because that's where the meat and potatoes of where the streamer will spend most of their time in our application. Since this is a brand new application, we're going to encounter a few inevitable pivot points, which we go over in detail. We'll dive into beefing up our development environment even more by adding hot module reloading with our Vite configuration, which proves to be tricky, particularly using Docker. Then tackle the meat of the application, which is creating our clip system. We'll be setting up our database models and the associations needed to make those work with our user record. We'll also implement our new streamer model using single table inheritance on the user record that we created in episode 1. We'll get the entire workflow functioning of creating a clip and displaying it in our index view. We'll also wire up Turbo in order to provide a seamless experience for navigating between links. We'll spruce up the application with introducing feather icons, and we'll implement React toast notifications that we'll make use of in many different parts of the application when a user interacts with something. Finally, we'll wrap up by introducing system testing with Capybara and Cuprite, and make sure that the functionality that we end up getting working stays that way by giving adequate test coverage to those features. It's going to be a packed episode with real-world architectural decisions. So let's jump right in and continue building. This is where we left off in part 1, and although it doesn't look like much, we've gotten the basic system of being able to sign in and show this information, both the display name here and the profile image, directly from their information stored in Twitch via the Twitch API. Now, to give this a little bit more flavor, we're going to take a look at the mockup that Claude made for us, and this is definitely along the lines of something that we would expect to see in this space. So we're going to start working on the theme for all of this and start making it look like something that is a real application. Since we're using React, there's a few ways that we could have gone about doing this, and what I have in mind is using a hybrid approach for relying on just basic HTML whenever we can and embedding our React components on a as needed basis. This will accomplish a few things for us. I think it'll keep the markup as simple as possible while also showing how the views engine works in Rails and not compromising on any functionality that we'll ultimately put into our application. I just got a very basic version of our dashboard layout working, and I'll go over it now. Right now, as it stands, this is what we currently see when we load the dashboard. And in order to get this going, I had to do a few things here. So we're going to use the Vite pipeline for this because we're going to be writing our styles in Sass, the styles that Tailwind doesn't support. So this would be like custom styles, that kind of thing. So we're going to add a new entry point, and I'm just going to call it dashboard. And we're going to put a file in here called styles.scss. And I am currently in the middle of going through, this is directly from Claude. This is their layout. I'm going through and slowly porting it over to a neater version that's Sass compliant. And I'll start to replace some of the custom styles with Tailwind so that there's as little styling as possible, because this stuff can really get out of hand very quickly. And it's a really big reason why I like using Tailwind CSS is it may be a little bit verbose in the markup, but it's easier for the entire asset pipeline because it's styling directly in the markup, which is, I think, a little bit more scalable and consistent. So we needed to create a new dashboard.html.erb, and that is going to go in our app views layouts folder. You can disregard this Claude dashboard for now. This is just where I'm keeping all of the raw code that Claude created for us for our mockup for the dashboard, and that's where I'm porting that over. So the dashboard.html.erb goes under the layouts folder for a specific reason. Any view that we render from the dashboard controller will leverage this layout. And I didn't know this. I don't know if this is a new thing in Rails, but by putting the the layout in the layouts file here as the same name as the controller, it automatically will detect that and load the dashboard.html layout instead of the default application.html.erb layout instead. So it's kind of a nice thing. It's another Rails convention over configuration thing that we're using here. I just fired this up, and right away, without me having to declare the layout, it worked. And I asked Cursor why that was, and it confirmed that it's a feature of Rails that it detects that. So in our dashboard.html.erb is the slimmed down version of all that code from Claude. And this is mostly just boilerplate. The important information for our style sheet is this right here. We're using the Vite style sheet tag Rails helper method from the Vite Rails gem. And we're declaring this is going to be in entry points dashboard/styles.scss. And my thinking on where we're going to put our JavaScript will be in a dashboard.js file as well, so that we can try to keep things as modular as possible. The majority of the app that we're working on now is going to be used from the streamer's point of view, but there are different views that will have different kinds of styling that we don't want to have coupled directly to styles that aren't going to be used. You'll also notice that in the dashboard here, we just have our static content. So before, we were able to pull out the display name and the profile image URL from the object that we're storing in local storage. So in order to get that going, we're going to create a React component that will render our sidebar here. And in our React world, we'll be able to leverage that user service that we created that automatically fetches that token for us. So we'll move on to that next. It's worth mentioning that in order to get Sass working with Vite, all I had to do was install the Sass embedded npm module. We'll add tag-d to save that to our dev dependencies, which you can see here in the package.json file. We have Sass embedded now added to our dev dependencies. Other than that, I didn't need to register a plugin or anything. I did need to take the Docker container down and have it start back up. And that was the only thing that needed to be done in order for the Sass to be rendered as expected. Before we move on to the component that we're going to put in the sidebar, I just wanted to check in and go over the changes that I just made here that will hopefully help us keep things separated and organized. So in the application.html.erb, this is the layout that we're using only for the sign-in page right now. And I just had to make some adjustments here to the styling. And the idea behind this is that we have a Vite JavaScript and a Vite style sheet tag that are specific to this and separate from the dashboard. And for our dashboard layout, we're following a similar convention. So we're using a Vite style sheet and JavaScript tag, but instead of it being application.css, we're going to go ahead and segment them into their own files for styles and the index.jsx. I had to backtrack here and point something out that I ran into later on in the recording that wouldn't make sense unless I placed it here. I mentioned that we're going to use Sass, and the functionality with the new Tailwind version 4.1, which is what we're using, doesn't allow kind of the commingling of Sass and Tailwind, as they're not using Tailwind as a plugin for PostCSS. Instead, they're wanting to take the approach of ridding any other CSS preprocessor in the build. So if you plan on having Tailwind with a Sass file, like if you have a project that you may have inherited or that you started or whatever, and a lot of the styles are written in Sass, and you're using that Sass style sheet to import your Tailwind components, it looks like that's not going to work. And there's a few different ways that you can get around that. Since this is an evergreen project, and it seems like that's the direction that things are going, and Sass is an older technology, this is all new to me. And I just found out that the modern CSS notation allows for some of the stuff that we get in Sass, like nested selectors and stuff like that. The browser support for it is going to be kind of limited. It looks like it's only gotten popular within the last 2 years. We're going to be using this in a WebKit based browser source in OBS. So any views that we serve from Rails to that should work. And I imagine most streamers are going to be pretty hip with technology and be using the latest versions of Chrome and Firefox. So it shouldn't be an issue. And I'll see how far it gets us without using Sass. But this is just a kind of another bugaboo that I ran into and had to share at this point in the video. So I went ahead and removed the Sass embedded npm module from our package.json, and throughout the rest of the course, unless I mention that we're going in a different direction, we're just going to try to get along with modern CSS technologies, preventing the need for Sass altogether. So really interesting. At this point, we've got it working with Tailwind and our current theme that we'll go over further in the rest of the video. So back to the rest of what we're going over. remember in part 1, we went over how we're being able to use a Rails helper to generate the markup needed to render both the props and the component name in the Rails view. And I abstracted that out so that we can use it for both the application.js and the dashboard.jsx file that we're going to be using. So it's using the same functionality, just being able to keep it segmented to the context in which it is being written in. So I added that in the shared folder here that we created, and you can see streamer auth is in there as well. We're going to use that in multiple components. So the component renderer just exports this function that goes through all of the Rails view components that have that data React component in the attributes there. And this will allow us to be able to send in just the components for the dashboard and have those renders so that we can keep things isolated. And in the future, if we ever have any other engineers work on this, they should see the pattern that we're laying out here and should be able to follow it pretty easily. There's a lot of opinions and an infinite number of ways that this stuff can be set up. And in my experience, it's less important of what pattern you follow and instead just design and stick to a pattern that the entire team can go off of and understand very quickly. And this would definitely fall under that category, in my opinion. When people go through and look at this, they should easily be able to determine that we're trying to keep all components related to the dashboard. This is going to have an index.jsx and a styles.css file. And any engineer should be able to see this and should be able to infer what pattern we're following here with these assets and what build is ultimately going to be outputted in our assets. Up until this point, Vite has not been able to use the hot module reloading feature that comes with Vite Rails out of the box. And the reason for that is because we're using a little bit of a different setup with Docker, and we had to make a couple changes in order to have a Vite service run in our Docker compose file. So I'll go over that now. In our Docker file, we are copying over another entry point for the Vite service container, and we declared that in our root file here, our root directory here in our project, and we just called it entrypoint.vite.sh to follow the same convention as the entry point for the Rails server. And all this is doing is installing the npm modules, and this notation here will go back to our Docker compose file, and under the newly declared Vite service that we have here, it will run this command, which is the official way of running the Vite dev server while using the Vite Rails gem. So getting that set up, we just bind the ports to the default Vite dev server port, which is 3036. Since we're using Docker for our network mapping here, we have access to this Vite hostname, which Docker will automatically resolve to the network port on our Vite service here. So we have to add that Vite hostname to the list of allowed hostnames for the Vite config, and we do that in viteconfig.ts here in the root directory. So underneath the server property, we'll set the host to 0.0.0.0, port 3036, and we have to add Vite as an allowed host here in order for the WebSocket server to actually connect. Another caveat that I ran into was using ngrok. Earlier, I was doing some research on how we're going to actually embed TikTok posts, which is the platform we're going to start integrating into Klipshow. And in order for those iframes to work, TikTok has an official web player that uses an iframe to load the posts that you're trying to fetch. They also allow for an API over post message to control the video player. We'll get into that more later, but in order to have those iframes load correctly, I had to use the ngrok hostname in order to have a secure connection loaded for the TikTok request to be made over a secure connection. The reason I bring that up is because this current configuration won't support HMR with going to our app through the ngrok hostname. The reason for that is we need to set up another ngrok service in order for that to work. And in these circumstances where we're testing the iframes functionality, I don't think it's important to have hot module reloading. It should fall back to our assets being compiled on request. And if it doesn't, we'll address that as we get to it. But to show that the hot module reloading is now working, in the dashboard section here, we have a component that we're rendering. This is the component that I was using to test out the iframe functionality. And if we go ahead and make a change here, like just adding a question mark to the heading, save it, and go back to our page here, I didn't reload this, and you can see the hot update actually happened. So this should mean that hot module reloading is working. I tried to cover everything that I had to do there with whitelisting the Vite hostname to work with our Docker configuration and the Docker file that we had to change and the entry point for Docker that we had to use for our Vite service now, because we don't need that service to run our Rails app, which is why we couldn't use the same entry point as the one that we're using for our Rails server. Another issue that I ran into while getting hot module reloading going is the error here from Vite.js plugin React can't detect preamble. Something is wrong. And if we go to our dashboard.html.erb layout here, it's crucial to include the Vite client tag, and since we're using React, the Vite React refresh tag. This is how I had it configured originally, and this is what was causing the issue. Making sure that the Vite client tag and Vite React refresh tag methods are called before we're including any of our custom JavaScript that Vite's creating for us. This ensures that all of the hot module reloading stuff is configured ahead of time, and that is what ultimately fixed that problem for me. These types of things always give me a headache, but it seems to be that once you get it set up, it's kind of a set it and forget it thing, especially with Docker. So if I run into any more bugaboos in the future, I'll be sure to include that. Now on to creating the first component that's going to be in our dashboard layout, which is going to render the streamer's name here, and it's going to get that from that object we're storing in local storage. I already created the component as you saw in the browser, so I'll go over how we're getting to that point. In our dashboard.html.erb layout, which is the layout that we're using for the dashboard controller, which is the action that shows this page here, despite which view is actually going to get rendered in the dashboard, we know we're going to want that sidebar to load on every one of them. So we're going to include the React component on the layout itself, and this is leveraging the same component registry approach that we went over in part 1, and I went over here with changing the different layouts that we're using to try to keep things isolated. So the React component helper method renders the user info component. In our dashboard.index.jsx file, we're mapping that user info component to our actual user info component being imported in JavaScript here, and the actual component itself lives in JavaScript components streamers dashboard user info index.jsx. And this is my best attempt so far to keeping this stuff separated while allowing for an easy path for expanding this as we build out more components. So all that the component does is render the same markup that we took from the original Claude mockup, and we're using the current streamer method from our streamer auth file here, which is just a helper method that retrieves the current streamer object from local storage, parses it as JSON, and returns it. It's also worth mentioning here that I'm using a alias here similar to what Webpack uses for aliases, but this is using Vite, and those are set up in the Vite config, and as far as I can tell, it's the same thing as setting it up with Webpack. And what this does is it allows us to use these keywords and to, no matter where we are in our directory tree, get to these core folders that we're having multiple files that will be shared or can be deeply nested. We have another update with the application, specifically with the authentication that we were using prior to right now. We were generating our own JSON web token, and I was loosely thinking when I came up with that we would have something similar to React Router, and we may go the approach of having a single page application. And the closer that we got to actually implementing this, I decided against it because I want to keep as much Rails a part of the equation as possible, because it really does take a lot off of our plate and can really end up simplifying a lot of things, kind of like what we're doing now. Although it's a bit of a trade-off, I think it's ultimately a win, and I feel pretty good about using this moving forward. So basically, instead of having our JSON web token returned from the OAuth controller here, we're now redirecting to the dashboard path. So how this came about was I started looking into how we were going to properly treat the sign-in page if a user is already signed in. Typically, from the Rails side of things, we'll just do something like this: redirect if signed in or something like that. Those helper methods come from devise, which is what I'm normally used to using in our own authentication system, where we're storing the password digests and we have the ability to register users on nobody's behalf, and we're not doing that this time. So now the auth token is still being used, and we're also adding another layer of security by introducing signed cookies. So basically what this will do is store a cookie in the user's browser. The browser will be set to include that cookie when someone clicks a link or navigates on the page. And what we'll use that for is checking to see if the cookie is set, if it actually returns a encrypted token. So there's two different layers of kind of security that we're getting there. And what this will allow us to do is store secure cookies in the client's browser, and we can confirm on each request that the cookie value hasn't been tampered with to try to thwart any kind of cookie replay attacks or session hijacking or anything like that. So we feel pretty good about doing this, and although it's a bit of a pivot, I wanted to keep it in the course anyway because I think this illustrates a real problem that I'm sure more than just myself experience while making these things from scratch. Early on in the architecture design of the system, you don't really know what problems you may run into until you start building it out. And you should always be questioning what problems you might run into from the very beginning, so that in situations like this, we don't have to rewrite a bunch of code and completely change the application's code base in order to have this new approach that we see a lot of benefit to being in place. So along with bringing this kind of stuff into the Rails server side of things, we were also able to remove the OAuth view entirely. So I removed the folder that we were keeping that view in. And what that did was communicate that post message call to the parent window that opened up that other OAuth window. Now, we did have to change our approach. I do kind of like the pop-up window for some reason, but we did have to change it so that the tab will actually redirect to Twitch's OAuth, and then that tab will redirect ultimately to our dashboard. So it was a bit of a trade-off there, but I think it's insignificant. And the meat and potatoes of this is in our authenticatable concern that we added here. So this is just under controllers concerns. Concerns are a Rails convention that ships out of the box with being able to make, namely your controllers or models, whatever it is that you're working with, more modular by having these kind of dependency injection happen and being able to do stuff like this, where upon the module being included, we can declare these helper methods within the context of wherever we're importing it. It's kind of a hard concept to explain, but it essentially is what gives us the ability to make our controllers more modular and split the business logic across something like a concern instead of having all of this code inside the controller itself. So we have a few methods that we're using here. The authenticate user is something that we'll call in a before hook on each of our controller actions that we need to make sure are authenticated. And what this will do is use another helper method here, which trickles down and eventually checks this method here. And if anybody is familiar with devise, this follows a very similar convention, calling these methods by current user. We may change this in the future to be current streamer, but for now, the only user that we're dealing with is a streamer. So we'll just take care of that if we decide to change it when it becomes necessary. So current user gets set in an instance variable here. And this is a bit of a Ruby syntactic sugar, I think they call it, where what this will do is store in the lifetime of the request the current user object in an instance variable, so that you don't have to make a database request on every single part of your application stack where the user might be authenticated. So once it's set the first time and the heavy lifting has been done of looking up the user by their decrypted ID we got from their token in the encrypted signed cookie, it is able to just return that stored for the duration of the request. So it's a bit of a performance thing, and it's a pattern that you'll see mostly with stuff like this, but anytime that you have a declarative syntax where you're wanting to do something like this, it's good to think if the approach of using this shorthand operator, I forgot what it's called, leave it in the comments below if you know what it is. But basically it just is a bit of a short circuit and will only set this if it's not already set, in other words. And if it's not set, in this case, it will call on whatever on the right hand side and then store it so that next time it will not get to this part. Other than that, I had a puts line in here because we were having some problems with the cookies. I was trying to get that pop-up window still working, but it wasn't worth the effort. So we ended up going the way that we did. And this should all be fairly straightforward here. We're taking that authenticated token, making sure that it's there. If it's not, then we return nil, indicating that the user's not authenticated. And then if it is, we'll decrypt that using our token service. Again, if that returns nil, indicating that it's been tampered with, then we'll go ahead and make sure that the authenticated request stops right there. Otherwise, it will trickle down to this here, where it will try to take the decrypted value, which should be the user's ID, find that user and return it. If not, it will return nil through rescuing the active record not found, which will raise if this doesn't return any records. And then we have a sign out method, which just uses the cookies rail. This by the way, is a method that's available to us within any kind of action controller instance, and that's where this actually gets defined. If you get confused in this stuff like I did early on in my career watching these types of videos, I would see stuff like this and I would be like, where in the heck is this coming from? So hopefully that's helpful by kind of calling that out as I think of it. But this is a method that comes from Rails. We're not defining that. It just gives us access to that. The Rails cookie jar is what the implementation is called. And this will just basically delete that and set the instance variable of current user to nil, which is all that needs to be done in this circumstance here. So if the user signs out, the next time they go in, regardless if they're trying to go directly to the dashboard or to the sign-in page, this will ultimately take care of all of that. We were also able to completely remove the user info React component, since we're not going to be handling that using the local storage JWT approach. We're still using the JWT, but it's all within that cookie now. So in in our dashboard layout, we were able to use just regular markup here and a nice Rails helper through Action View that will allow us to use a sign out link. It's going to look like a regular link, but in the actual source code, it will be a form, because how this is going to work is it's going to use the delete HTTP verb, and you can only do a GET request with a regular hyperlink. So in the routes.rb file here, we can go ahead and add the delete method here. So this is declaring that delete HTTP verb. Type of request to log out will be directed to sessions controller on the destroy action. And the sessions controller here just has one method so far. It will include that authenticatable concern that we went over. And the destroy action just uses that sign out user method that we went over and then redirects back to the root path. So to demonstrate this, we have to make sure that our ngrok instance is working, because we need to expose our development environment to Twitch in order for that OAuth request to come back and do all of the stuff that happens on that authentication endpoint with the OAuth controller. So if we hit the continue with Twitch button, instead of a new window popping up now, we're redirected. If I wasn't signed into Twitch already, I would have been redirected to that stage first, and then the same window will redirect us to our dashboard here. And then at the very bottom, this is where that user component was, and now we are just using that regular markup with the form here from Rails. So if we actually look at what gets rendered here, it's a form. So it's an HTML form, and it's wired to a button. This will include the authenticity token with it, which we're not using. That's if we were using Rails sessions, which we're not. We're just storing our own cookie that is associated to a JSON web token, which has their user ID. So it's actually not necessary. We may remove that in the future, but it's just important to know that instead of an actual link, to make this work and look like a link here, what's happening behind the scenes is this form. It submits a post request, but it has a hidden value here that Rails will interpret as a delete action. So that's how that works, and a bit of a hacky thing, but Rails makes it really easy to just work and function out of the box. So if we go ahead and hit sign out, what will happen behind the scenes is that cookie will get cleared, and now if we go to the sign in page, we'll have to sign back in. If we try to go to the root URL, which goes to the sign in page right now, once we're already signed in, we would expect that to redirect us to the dashboard here, which it does. So this accomplishes the original functionality that I was seeking out to solve with our local storage approach, but I think this is going to work better considering that we have these Rails helpers and it's not deviating too far from the standard Rails devised kind of tried and true way of doing things. To start to get our Clips experience built out here, we're going to need to add a link in our sidebar navigation to the Clips view. We'll also need to add a Clips controller and routing for Clips, since we haven't done that yet. So we'll go over that now. In our routes.rb file, we're using the Rails resources method to create routes for our Clips model. And right now we're only declaring that we want the index action created for us. So resources is doing behind the scenes what we would otherwise have to type out like this, and it's doing it in a more declarative Ruby-esque type of way. At any point, to see what routes Rails has configured for the current application, from terminal, you can just run Rails routes. And a lot of the times, particularly if your routes file starts to get large, you can pipe the output of that to grep and only use keywords for what you're looking for. So for example, if we wanted to see what routes Rails has created for our Clips model, we can go ahead and run from terminal Rails routes and pipe that output to grep, only finding lines that match our keyword here. So we can see this creates a path to /clips, which will route it to the Clips controller on the index action. That controller and action hasn't been created yet, so we'll go over that now. In our app controllers directory, we're going to add a file here called clips_controller.rb. That is going to declare a standard Ruby class, and we're inheriting from this new dashboard base controller, which is this controller here. And this is including everything that we would otherwise have to include on each of our controllers that isn't directly relating to the root dashboard view here. And since that's repetitive, we can use this pattern here of declaring a base class, since all of our classes that will inherit from this will need to have access to the authenticatable module that we created to handle our cookie-based authentication now. We're going to be using the dashboard layout. As I mentioned earlier, the dashboard layout will match that controller, but since we have this set up to where dashboard is the root view in the dashboard, and it's only going to work for that controller, and we're separating it for the Clips controller and other resources that we'll build out. So we'll need to make sure that we're declaring dashboard layout, which in this case is a helper method. And we're going to get to this in just a moment, but we've added turbo to the application to make sure that we can have a seamless user experience. Again, I'll go over that in just a moment. Instead of this just being a static declaration now, it has to be dynamic and determine if the current request to the controller is a turbo frame request, that we need to use the turbo rails frame layout instead of our dashboard layout. If it's a normal request, then it will render the dashboard layout. And so this Ruby class is set up to be inherited from our Clips controller and other resources that we'll have very shortly. While going over that part and how the dashboard base controller was working, one of our live stream viewers actually asked if there's a better way to do it, potentially. He asked about using a concern instead of the pattern that I was showing here by using a base class, and I built it out to demonstrate that it can work that way too. And I kind of like the ability to include this very Rails-oriented kind of way of doing things here by using this dashboardable type of nomenclature. So I actually think we're going to use this instead. So shout out chat member, you know who you are in this video. I won't name names because I'll be respectful, but I wanted to keep this in the video to illustrate that this is a real development process. We've pivoted a couple times on different things, and I think it's really important to illustrate that, at least for me, this is a typical process where things will change fairly quickly when you're first developing something, and you won't always get it right the very first time. When I was very early on in my career, and even still, this led to imposter syndrome, thinking that if I didn't get it right the very first time, then I was a lousy engineer. And although I am far from the best engineer that I've worked with or that I've seen, I do have experience and can get things done. And if you're running into a roadblock with your journey, give yourself some grace in that this is a constantly changing environment, and it's part of what keeps us excited about the industry, but don't let it hinder your motivation or progress, because I have well over a decade of experience in this, and as you've already seen, there's been a lot of issues that we've had to work through, and that's just how this game works. So instead of inheriting from that dashboard base class, we're going to use this include dashboardable on all of our controllers that are going to have a dashboard based kind of functionality. And we're using the dashboard controller here as this root view. So our content that will go here, which was ultimately this in our Claude mockup, we will have something more like this once we get to this part of the project. But for now, we need to start with being able to build out clips, and that's why we're focusing on this first. But it's kind of a preview into what it will look like very soon. Since we're using a cookie-based approach here to keep all of the routing on the Rails side of things, we introduced a problem with having the page refresh on every single link that is clicked. You can't see it now because I have turbo going, but in between these navigations, the page would have to completely re-render, and it would show a flash on the screen, and sometimes the assets would load before the styles did, and it just was a suboptimal experience. So the aim of turbo is to hijack the local links that are clicked here and only replace the body of your turbo frame with the response that turbo will go and fetch for you, which is ultimately just making another request to the controller that we're building out, and will render the view as you would normally expect. With our clips controller created, we can go ahead and add the views, which we'll do under views, clips, and this folder needs to match the name of the controller. That's no coincidence there. That's how Rails convention kind of works. And then we're going to add an index.html.erb file here. And this is the view that will load when we are going to our clips link. And if we go back to the browser here, we'll see that nothing else actually loads or changes than what's to the right here. And what's happening is Turbo is providing that seamless kind of functionality for us. So if we look in the network tab in our dev tools here and click on one of the links, we'll see that the initiator of these different requests, which is just a regular HTML request, is our hotwired Turbo Rails JavaScript initiator. So that tells us that that's how that functionality is actually playing out. It's not an HTML request that's just loading over the wire regularly. It's being handled by the hotwire Turbo Rails package here. To get that set up, I had to add two different dependencies, one here in our gem file, which is turbo-rails, and then another here in our package.json file, which is the @hotwired/turbo rails, current version at least 8.0.16. We'll need both the node and the gem file dependency in order to make this work, because we have to have a little bit of Ruby code executed as well as having some JavaScript set up to be able to hijack hijack those hyperlink requests and be able to, instead of navigating the page, change the history API and load the content from the request to that endpoint, which would simulate the user actually being sent to another page, but only part of the page is being reloaded. Another benefit of keeping things modular with our layout and how we went over that and got to the point where we can keep things organized like this is we can make sure that only the parts of our application that are going to leverage Turbo will have that actually sent over the wire and included in the client's browser. So what we're doing here is we're just importing the hotwired Turbo Rails package. And then in our dashboard.html layout file here, we're going to add this Turbo frame tag, giving it an ID of dashboard. And this is the unique identifier that Turbo will use to know what container in the HTML it needs to replace the inner contents of when these Turbo link requests happen. So this is how we're able to maintain our view changing to the right while the sidebar stays static to the left. This is the frame that actually gets reloaded, and this just stays on the page from the initial page load. We also added a heading here in our shared directory, which is a newly created folder. And if we go to views, shared, we'll see using the underscore notation here, we have underscore heading.html.erb. The reason we have an underscore here is Rails convention will treat this as a partial piece of code instead of a full HTML view, and will work well with this kind of render syntax here. So we don't have to use the underscore here, but if we have the file name itself saved with an underscore, Rails will know that it's a partial and will load that markup as you would expect. In this heading.html file here, we just have a basic div that is using some Tailwind CSS classes here. And we're using this yield block again only if we have content for. This is a method that comes from action view and will allow us to, in a declarative way, inject code to this partial from other parts of our application, namely the dashboard views that we'll be building out. So we're using that in two different locations here. And how that works is in our view that we're going to actually render. So for example, the index.html view for the Clips controller, we can add these content for blocks. And if we send it a block, it will render whatever you send it here. So for example, we're sending clips here, and that's what allows us to change the output of this area here. So it's really nice Rails syntax for being able to separate your view logic this way. And once we get to the point where we'll start building out caching, having partials separated like this will really serve to our benefit, because we'll be able to cache at different levels of our view structure and not just the entire page if we don't need to. Another thing that I added here was an active class helper method, which I can go over now. So in our application helper file, I added another method here, and basically it's just taking in the current path that we're going to pass it and the target class. If the path matches the class, we'll return the class. If not, we'll return nothing. What this allows us to do is conditionally render this active class, which we have styles set up for, which gives us this selected state. So it's kind of another nice thing that stays all within Rails and HTML and requires very little heavy lifting to just have it work really well. Really well. Okay, so we have a good starting point for being able to navigate and dynamically load between different sections of our dashboard using the new Turbo integration, which seems to be working well. Now let's move on to actually building out the functionality of the clips area of the dashboard. And we'll start with adding the clips views to our dashboard styles page here, which is where Tailwind is getting set up. And we'll do this so that anything in the clips directory here will get picked up by Tailwind via Vite watching it, and we'll get all of those styles applied that we can add in the classes to the views here. Another thing that I've added that I don't think I've ever used before is something called feather icons, which when I did some quick research on the best open source icon library, this came up and it seems to be pretty lightweight, so we'll use it for now. To get this to work, we'll just add their link to the CDN to get their minified version of the library loaded onto the page. And then in the body tag here, I added another script that just calls this feather.replace function. And what that will allow us to do, as you'll see here in just a moment, I'll go over this new .html view that we have here for clips, but anywhere in our markup that we have this data-feather attribute, we can use their notation to include an icon very similar to like font awesome, and that call to having the feather.replace in the layout is what actually makes that happen behind the scenes. Before we get too ahead of ourselves with creating the views, it's very important to know what it is that we're actually going to be building out from from the database perspective of things. So I drew this table here of the columns that I think we're going to need for two different tables, one being the clips and the other being streamer clips. The idea is going to be that either a viewer on the ClipShow network or a streamer on the ClipShow network can add a clip to the ClipShow database, and that will be the source where either just that streamer or a combination of other streamers that are using ClipShow will be able to have that as an approved clip that they can offer their viewers to show on stream. So the clips table here will include the platform, which at first will just be TikTok, platform ID, which will be the video ID that we're going to derive from the URL of the post itself. And then this shareable is going to be a Boolean field, and whoever's uploading this clip is going to set that. If they toggle this option off, they don't want this clip to be a available clip that other people can use on their streams. Shared by will be a foreign key that we'll use to tie the original uploader of this clip to if we ever wanted to display that and give them credit. And then the shared by type will either be viewer or streamer, allowing us to indicate we need to look up the shared by using the viewer model or a streamer model. Where it may get a little bit complicated is where we bridge the gap between individual streamers and the many clips that they can have in their library. This is going to be using a joins table, and in Rails, active record allows for us to declare this type of association relatively easy. To try to illustrate this, I created a few more blocks of our streamer clips model here, and what this is going to associate is that if we had 3 different streamers that all had the same clip in their library that they can offer their viewers, this is what it would look like. There would be one clip record in the database, and that would be referenced on multiple of these joins records that are going to have the ultimate clip record associated to it with this clip ID foreign key that we're going to set up. This will give us a very similar relationship to the Rails has and belongs to many association. My preferred way of doing things is to create the join model yourself so that you can add columns onto the joins table here, which works really well for us for things like play count of this individual streamer clip, the cost, which is going to be dictated by the streamer for just this clip here, the streamer themselves, and if there's any other metadata that we want to associate to just this instance of the streamer's clip, we can do that using this approach. The Rails has and belongs to many association allows for very similar functionality in the sense that you can have and belong to many in this type of association chain here, but it doesn't give you an interface to declare that model or to set any of the columns on it yourself. So for more complex issues, I just find myself always using the has many through, even if I'm not going to have any of these extra columns on the joins table, because if I ever need to, I don't have to create a new model in my database or anything like that. It's already set up. We'll need to generate a migration that will create both of these tables for us so that we can declare the Ruby class equivalent of each of these tables and set up the associations to work in the Rails side of things. Initially, to generate this file, I just used the Rails generate migration command and adding in the add clips and streamer clips in snake case, I believe is what it's called when it's all separated by underscores, and it created a blank migration for me with the timestamps in the file name. And what I did here is declare the clips table, and it's important that this gets created first because I also declared my associations in the model files, which I'll go over in just a moment. And this is just declaring our very simple columns that we'll have at least at first. The t.timestamps is a helper method from Rails that allows us to add a created at and updated at column on this record, and it will automatically get touched by Rails unless we tell it to not update that column. The streamer clips table is going to have a few more columns on it. This t.references method is another helper method from active record migration here, and it will set up a few other columns and just makes the migration a little less verbose. And what it's doing in the background here is setting up this foreign key to be associated to this table, and that will also take care of adding a database index, because anything that's going to be searched by in the database, like a foreign key on a relation here, needs to be indexed. So the t.references method is really nice in handling that for us. Another thing that's worth mentioning here is on the status, we're going to add a default value of pending. By default, the price will be 1. The plan for this is to use this as the number of tokens required in order to have this clip played on stream. And then the play count on the streamer clip is just going to be a counter for this specific streamer, and we'll use that for some of those analytics that we've seen in our dashboard views of the mockup earlier in the video. Since we're on the topic of migration, it's worth mentioning that I've added the strong migrations gem to the ClipShow app. And this is something that I like to use to make sure that the migrations that we're running are following best practices for zero downtime deployments and are creating safe environments for our migrations to run, giving us the least likelihood of data corruption or any other database related issues we may run into, particularly running this in production. To install it, we just add it to the gem file and run the Rails generator for strong migrations install. And this will create a initializer, which will have strong migrations run every time that you run your migration. And if strong migrations detects that your current pending migrations have any problems with it, it will raise and give you a helpful suggestion in the terminal output. So it's a really nice gem to use, I think. The first iteration of our sign-in process was using just the raw user class. And we mentioned how there's going to be a streamer and viewer class also used in the application. The idea behind this concept is something called single table inheritance, which is something that Rails provides a support for right out of the box. Basically, in our database schema, there's going to be a user table. The user table is going to have a type column, which is going to be a string that will hold the name of the class that ultimately is being represented by this record in the Ruby side of things. So for example, when we go to create or sign in a streamer, we're actually getting a user with a type of streamer because that's the class that we're associating to this. The same thing with a viewer. In different scenarios, they'll be treated differently, and we'll need to know that. And it's good convention to try to use this type of approach so that we're not segmenting too much of our functionality across two different type of records that will be treated the same but different in certain areas. This is a really good pattern to follow for when we know we're going to have very similar functionality on the database level, but we might have different methods for each of these and different associations tied to them. And all of the plumbing for associating a streamer to a user record with the type of streamer is taken care of for us in Rails as long as we set this up correctly. Since we have our user class declared and already set up, we just need to create a streamer class. Instead of inheriting from active record directly, it'll inherit from that user class. This is what allows Rails to tap into the classes that inherit this master class here, and that's how Rails knows to set that type column on the user record to the associated class. Now that we have a streamer set up, we can go ahead and create the associations that only streamers will have. This goes back to the other slide that I was showing where we go over that has many through association, and we'll start to set that up now. So we know a streamer is going to have many streamer clips, and that's a model that we haven't gone over yet, but will in just a moment. And the option that we're passing in here is that if a streamer gets destroyed, then the streamer clips will also go with it. So if at any point in our application we decide that a streamer can be destroyed, we're not going to keep stagnant data that can no longer be legitimately used within the application. So Rails will handle that automatically if that does happen. And then we also have many clips through our streamer clips association. The through flag here is how Rails knows how to treat this association and extract the necessary information following this naming convention that we've declared. Now we'll declare our streamer clip class, which will be associated to the streamer clip table that we're creating in that migration we just went over. We're just declaring that this belongs to a streamer and a clip. A good way to remember the actual difference between the belongs to and has many methods when doing this kind of thing is to remember that whichever class has the belongs to associated on it will be set up to have a foreign key on that model instead of the parent model. So in this case, our streamer clip is our joins table, indicating that we have both a clip ID and a streamer ID, which is the same in our migration and in our diagram that we went over. I also have some scopes defined here. These are just in case we end up using this in functionality we might build next with showing only clips that have certain statuses. And then the last class is our clip model, and this is just setting up the rest of that has many through relationship. We are able to have many streamer clips and also have many streamers. We're having many streamers through the streamer clips table. And then I also added a scope for shareable to allow us an easy method for getting all of the clips where the shareable flag is set to true. Since we're now using the streamer model instead of that generic user model, we'll need to replace any mention of user currently in our app, which is only in the OAuth controller. So anywhere in our OAuth controller where we currently had user mentioned, we'll have to go through and set that to streamer, and that will allow us to keep the different models segregated based on the types that they are going to be interacting with on our app. At this point, in order to get our existing user that we've been testing, which is just my personal Twitch account, we would have to manually update that type column in the user record in the database to have the streamer class on it for this to be mapped normally and to work. work, or you can just drop the database and start over. Since we're in development, we didn't anticipate if and when we would make the change to using single table inheritance, so it's not a big deal that this has happened again because this hasn't made it on anybody else's machine or into production. It's actually worth mentioning that we were using the user model in the authenticatable concern, which we'll have to update to using mentions of streamer as well. And then I'm changing the method names to reflect that so that once we start adding the viewer authentication, whatever that may look like, it should aid in keeping that stuff separate as well. Since we have our models all set up, now it's time to take care of the routes and the views that will actually render in the dashboard. In routes here, we're extending our resources clips to add a new and create route here, and we're going to leverage both of those views in order to create and actually store those clips in the database, and we'll go over how that works in just a moment. So in our clips controller here, we're adding two new methods, both new and create, and what new is doing is just instantiating a new instance of clip, and we're going to leverage that in the new view, which will store the form that the user will fill out to ultimately have the clip created. The new method will have a form on it that submits to the create endpoint. And what this will do is save the clip if it's able to save, indicating that it's passed any validations that we may add to the model itself in the future. We're going to go ahead and create the counterpart to the streamer. We're going to go ahead and create the counterpart to the streamer's part of that clip relationship and have a streamer clip created for the current streamer that's signed in combination to that clip. So if the clip was saved, we'll go ahead and add that clip to the current streamer's streamer clips, and this will allow it to be available in sections of our app where other streamers may be able to go and add those shared clips to their library if they've added that shareable column, of course. Either way, it will make sure that the streamer themselves have that available in their library to use. And then we're just redirecting to the clips path here, which is going to be our index action. And this should show us our newly created clip along with any other clip that we've added. The only other thing that's jumping out at me to go over is the strong parameters here with Rails. Since we're taking input from a client, we need to make sure that any property is an expected property being sent to the create action for the model. And we're able to do that by whitelisting the parameters that we're expecting. So the convention for doing that is declaring a private method, usually around the resource that you're using. So in our case, it's going to be clip params. And then to do that, we're taking the params method that we're getting from Rails, and it has a require method that we can call, indicating that the parent object is going to be called clip, and we're allowing these fields to be populated on that. What this will ultimately do is strip out any columns that may have been added by the user to try to do something nefarious. We're also whitelisting the statuses that are going to be available for the clips on here. And the reason we're doing this is because, again, this is input from the client that needs to always be treated as not trustable. And we're trying to hedge against that by having a whitelisted name here, similar to our params here, by just storing this in a constant of the only statuses that we'll accept them to pass in, just to make sure that they can't trigger any unexpected functionality at this point in our app. At this point, we can go ahead and update our index.html page to get ready to render the collection of clips that we may have stored in that instance variable and conditionally display a different element on the page if there are no clips in the library right away, so that they're not left with just a blank page to look at. So this is just adding to that. Really nothing special here other than just a little bit of markup. We have a generic select element here that we're using to try to emulate that dropdown that Claude made for us in our mockup for the different statuses you can see clips under. And this is how we're able to conditionally display if there are any clips. We will go ahead and render the clip themselves, and we'll loop through and do that. If not, we'll render a dialog box that indicates that there are no clips with a nice little button to go ahead and add the first clip. So this is basic CRUD actions, or create, read, update, destroy, that we're starting to build out. And this is core functionality for our foundation to build more off of that will get closer to what the users will ultimately see. Refreshing our application here, we can see this new page where it's actually starting to come together with that drop down here of all of our statuses that we allow. That nice button that shows if there's no clips, which currently there are not. And we also have another button here at the top right for adding a new clip. And the anticipation there is that as we add clips, that'll be the easiest call to action for the streamer to click on to add a new clip that they'd like to share from social media. So we want either of these buttons here to ultimately render that new page that we're going to go over in just a moment and have it render on the screen without updating the sidebar here. So to add that button in the top of our screen, we're going to, in our index.html.erb, add the content for heading nav here. And this is leveraging that mechanism where we're able to update parts of the application outside of our view context using this approach here. So we're just creating a link using the Rails link to method and passing in the new clip path, which we're getting from declaring the resources for clip and specifying that we want the new path specified in that file. And it gives us access to this helper method here. And then we're just passing in some classes from Tailwind CSS to try to style this a little bit better. We're using a feather icon here to give it a little bit of pizzazz. And that's it. This will render inside of its turbo frame and should leave the sidebar intact or seemingly intact and without triggering a page refresh. And down here in the section where if there aren't any clips to add a new clip, we're doing the same exact thing, just copying and pasting the same thing here. And one thing that I did notice is that with this one, I did have to specify data turbo false. For some reason, in the context of our content for block here, it wasn't causing any issues. But since we're rendering this in our view, we had to specify that this isn't going to be a turbo stream request is what I found out. And it's going to just be treated as a regular turbo link that will load within the parent frame that we have, which is just the dashboard container. So I did have to specify data turbo false for this link and the other link that you'll see in just a moment in order to make that work. What was happening initially was this section here, when I would click on a link, it wouldn't load the new view here as you'd expect. It just showed no content. And the reason for that was it was expecting from our controller a specific format to respond to that we didn't have it set up for. And that wasn't necessary because we're just trying to keep everything in this context here its own frame. And so far that is working. So I thought that was worth mentioning. And my experience with Turbo when it was originally Turbo Links was very much a mess. So I'm still conscientious about how this is going to work out, but for now it seems to be doing what we needed to. So in our new .html.erb file, we're leveraging the same mechanism here for being able to specify the content that we want in that heading part. This is just for a link to go back to the clips page. Here we're using the form with helper method, which is again from action view, passing in that instance of that clip that we're creating from the controller, adding a little bit of Tailwind here. And again, we're creating this turbo false so that it doesn't expect a response that I don't think we're going to need. And the page should load correctly as we would expect. We're taking care of any error messages here. Once we start to add validations on the clip model, those errors will be shown if they go to try to save that clip and there's a problem with it. We're re-rendering this view. So if we re-render that view with the same instance that has those errors on it, this will aim to get that and list it in a unordered list here on the page. And then we just have some inputs here just to try to make this work. Again, we will add more functionality here and validate the data and all that kind of thing. But since we're using the form with method here, we get access to this block that we can have associated to that form object. And it gives us the ability to create text fields that will ultimately render in HTML. Again, this is another Rails helper here. We're just trying to keep it as vanilla, as basic as Rails as we can. And that renders this page here, which if we just were to type in any kind of string and add it, a couple things happen here. We're being redirected to our clips path here, which is showing all of the clips. Right now, it's just showing that one column on it. And we also saw a nice little toast message appear at the top right. And that is a new addition that I'll go over right now as well. So I did add a dependency here, and I normally don't like to do this kind of stuff, but I really like the react-toastify npm module. It just seems to work really well. And I've added it to ClipShow here, and I'll show you how we're able to have it work without having to have the component that triggers it be in React. So in our JavaScript components folder here, I created another shared folder here under the toast directory, which I also created, and putting the index.jsx file here. This is where we're actually going to have our component use that toast React package to have that toast message ultimately display. So all this is doing is importing the toast method from that npm module, and anytime that our prop, which will just be notice in this case here, changes, it will use the toast success function, which is ultimately what triggers that toast message to display. And it comes with the functionality of being able to dismiss it and have it time out automatically out of the box, which is why I'm willing to add it as a dependency, because it really does seem like it is a easy, simple, well-maintained package that we should be able to lean on for this nice functionality. So since we're going to be using this in the dashboard area, in our dashboard index.js file here, we'll go ahead and import our new toast component here, which we're using our components alias for to get to that shared directory easier. And we're registering it here as toast, and that's what we'll use use in our Rails view to reference this. It's also worth mentioning that to get this to work in our component renderer function here, where we're rendering the component itself, I also am rendering the toast container, which comes from the toast package as well. And that toast container is what the underlying package uses to mount all of the contents in. So adding it here as an adjacent element seems to work for us. And then ultimately in our dashboard.html.erb layout file, if we have any flash messages, and those are a mechanism used in Rails to get messages between one request to the next, showing some sort of error or response message. If that's set, we'll go ahead and use our React component helper method, passing in that toast string that is referenced ultimately to the React component that does all of that. And we're passing in the notice parameter here, which is the notice of the flash alert that will be detected from this if condition here. At this point, we're starting to get some really solid functionality ironed out. And it's at this point that I want to make sure that the functionality that we've gotten working in a theoretical basis is tested and something that we can continue to build off of. So we need to add tests for the functionality that we've changed and added. To get our spec set up with having the ability to emulate having a user load the page and make assertions around the state of our application to give us some added security that our application is working when we have a green passing test suite, we need to add a few files to our gem file here in order to make that work with our spec. So we're adding a few things here. We're adding Capybara, which is used for actually writing the tests in for our system tests or integration tests. And I have it on good authority that Cuprite is currently the most stable way to have a Chrome web browser driven with Ruby. And this comes from a good friend of mine, D-Dubs. Thank you, D-Dubs, for the recommendation here. We're going to be using the database cleaner active record gem. And what this will allow us to do is easily clean the database after each instance of our system tests running to make sure that each test has a fresh version of the database and we don't have to worry about stale state from a previous test run. We're going to be using factories, and that requires the factory bot Rails gem. I like using guard, and we're going to be using the guard rspec package for that. We already have rspec Rails here, which was moved from the development group because I think it just needs to be in test. And we're using the web mock gem in order to mock web requests, namely for the HTTP request that's going to be made to the Twitch servers for our sign and stuff. We're going to want to be able to prevent those web requests to making it outside of our test server. Right now, we're mocking that directly in RSpec, but using the web mocks is a little cleaner approach in that we can ensure that any request that tries to make it outside of localhost will raise an error and draw our attention to an issue that we need to fix. Since we're going to be having Capybara use Cuprite or Cuprite, however it's pronounced, to run our integration test for us, I'm going to add another service in our Docker Compose file here that will just be responsible for running our headless version of Chrome that will set up to remotely communicate with our tests, which are running on the web service. So to do that, we're just declaring the Chrome service and using the latest version of Chrome image, which is 1.61.1. And we're going to use port 3333 from this service to the rest of our containers. And we're just setting a couple of environment variables here. We'll need to configure RSpec to use Capybara and to use the Cuprite or Cuprite WebDriver. So in order to do that, we're going to go ahead and create a spec support folder here. And this is going to be for different things like we have Capybara set up here, database cleaner, our Vite helper, and the webmock helper, which we'll use as well. So this is a pattern that I follow to have those types of files in one folder. And then in our Rails helper file here, we can have all of the RB files in there programmatically required. So anything that we need run like this, like an initializer or whatever, we can just put in this folder now and it should work. In our Rails file here, we're going to require Capybara RSpec, Capybara Cuprite. We're requiring all those support files. And then in the RSpec configure block here, I'm adding at the bottom, each system test will be driven by our new ClipShow Cuprite driver. And we'll go ahead and go over that. It was kind of a bugaboo. It took me a while to figure out why our WebDriver wasn't getting set up correctly. And we're doing that in the capybara.rb file underneath support. And we're doing the Capybara register driver, and we're calling the ClipShow Cuprite. In the documentation, it says to register the regular Cuprite driver. there's something else in the require chain that is declaring that driver and preventing this method from getting called with that from executing this block. So in order to get around that, I just created a newly named driver altogether. There's probably a better way around this, but this is working for now. So we'll go ahead and stick with it until we figure out a better way if we need to. For database cleaner, the only gotcha that I ran into was this URL allow list. Since we're using Postgres in a container through Docker, it's detecting that as a remote address, and it has a safety net in place to prevent you from cleaning a production database. So we just need to whitelist the name of our database, and this is using that Postgres host name that the Docker network mapping is setting up for us. Other than that, we're just doing, I think, everything else that is from the documentation for database cleaner, namely making sure that before each of our tests, we're using the right strategy. In this Vite helper file that we added here, we are just making sure that our assets are pre-compiled before running the entire test suite. That way, anything that's rendered that we're trying to make assertions around will hopefully get rendered correctly in Cuprite. In our Docker dev helper file here, we added a few things to make sure that our integration tests are going to work, whether we're using the watch command through guard or the newly created system test that I added here, which allows us to just run the system tests. Either way, we need to pass in the Chrome URL environment variable and make sure that we're using that Chrome host name from Docker and the proper port. And then this webmock helper is really useful for signing in and making sure that we can adequately test the different responses we may get from the OAuth requests that we send Twitch in our OAuth controller, and that's all handled correctly in the specs that we're going to write. So these are just some helper methods that stub the request, which is a webmock method that we're using to properly stub this with a response that's expected or not expected, and make sure that the controller responds as we expect. So we're just declaring this as a module here, and then at the bottom, we're calling the rspec configure include Twitch OAuth mocks here in order to have access to that. And then since we're adding integration tests here, we need to be mindful of the tests that we're putting in our controller specs and the tests that we're putting under our system specs. There are certain functionality that we can only test in a controller or should only test in a controller, like the different responses from an OAuth request. And then we should also make sure that the end result of what the user experiences is what's expected as well. And there are certain nuances between that I'll try to cover as we go. But the OAuth example is a great call out for a proper controller spec versus just having system tests, in my opinion. So here we're just able to make sure that we're mocking the different possible outcomes of that OAuth request and making sure that the application can handle it correctly. And then we're also able to take advantage of it in our system test here for making sure that the user can get properly signed in without a request actually making it outside of our local network. So we're just calling those in a declarative way and making sure that when we go, for example, we visit root path, click the link to continue Twitch, and this is simulating the callback that we would get if that request was actually made. And the result of that should be the user landing in the dashboard, and we're able to confidently say that that can happen and that the user was created, for example, by doing this in this declarative way here. And if we run our entire test suite, we should see that we have all tests passing, both the system tests and the controller and service tests that we currently have in the test suite. So to do that, make sure that you rebuild your containers to make sure to get that new Chrome service set up. And then if we run our entire test suite here, it takes a little bit because of those system tests, but we have 12 examples, 0 failures, which means we should be good to go to start continuing to build out functionality for Clips. And that's going to be a wrap on episode 2 of the ClipShow build series. We've covered a lot of ground today, from pivoting away from SaaS and changing our authentication strategy from using a local storage JSON web token to using secure cookies, getting our Rails dashboard set up and dialed in hopefully, sprinkling in some React components with that toast functionality, and doing a deep dive into the database design behind the models needed to make all of the clip functionality work. On top of that, we got turbo wired up, converted our user model to use a streamer equivalent, and we had that hooked up using single table inheritance. And we got the end-to-end creation process of a clip done in its most primitive form, which is a strong achievement at this stage. It wouldn't be complete, in my opinion, without making sure we have thorough testing, and we went into that as well, setting up Capybara and Cuprite. In episode 3, we'll be continuing to build out the clips functionality and start tackling some of the more complex features that'll really make ClipShow shine. Make sure to subscribe if you haven't already. These builds are going to get very in-depth, and you're not going to want to miss what happens next. Friendly reminder, I do stream every day at twitch.tv/oddjob, where we do game, but mostly write code, working on ClipShow currently, and we're just having so much fun working on that together live. So make sure to head over there now and follow us so that you catch us next time that we go live. Thanks for hanging out with me while I continue to build out ClipShow. My name's Johnny, and I look forward to seeing you in episode 3.